Okay, good afternoon, everyone. Guys, please type in your name in the comment box. Let me know first who are there. Then we can start with the session. Okay, I think some of you have joined, will join after some time. So we will start the session now. So today we are going to discuss the question of redox reaction. Okay, so here is the first question of redox reaction. Which of this following is not a reducing agent? Tell me the answer. What is the answer of this question? Okay, you see, the reducing agent or what? Which reduces other and itself oxidize. Okay, so reducing agent reduce others and oxidize itself. Okay, so when oxidation takes place, means the element should go under oxidation. The compound should go under oxidation. When oxidation takes place, what happens? Oxidation state increases. So we have to check that which element in these compounds is at its maximum oxidation state. because when the maximum oxidation state is already there, then further increase in oxidation state is not possible, and hence that compound won't act as a reducing agent. Okay, so you see here H2O2, SO2, CO2 and NO2. First of all, SO2, the sulfur is in SO2, H2O2, CO2 and NO2. These are the four options we have. SO2, sulfur is in +4 oxidation state. H2O2, hydrogen is in +1 and oxygen is in -1 oxidation state. CO2, carbon +4, NO2, nitrogen +4. Right. We know for nitrogen, pentavalency is possible. Valency is possible. It means it can go under oxidation if the condition is there. For carbon, you see, for +4 is the maximum oxidation state of carbon. Right? Maximum oxidation state means further increase in oxidation number is not possible, and hence it will not oxidize further. Oxidize anymore. Because +4 is the maximum oxidation state of carbon. Okay. Similarly, O2 also, oxygen can go into -2 oxidation state. That is also possible. And here sulfur is in +4, but since sulfur contains d orbital, it can show furthermore oxidation state. And we know the compounds of sulfur exist as sulfur SF6. Okay, there are many compounds of sulfur we have which has more than in which sulfur has more than +4 oxidation number. So only CO2 can not go under oxidation, right? Since carbon is in +4 oxidation state, which is the maximum oxidation state of carbon, and this carbon does not contain d orbital also. That's why it cannot expand its octet, right? Does not contain d orbital. Hence, the answer of this question is CO2, which will not oxidize further and it won't act as a reducing agent. Okay, answer is option C. Question number 2. What is the answer of this question? We have to find out the equivalent weight of KbRO3 in the following equation. Okay, so we just have to find out. Okay, equivalent weight we have to find out, and the reaction is already balanced. Okay, so we don't have to do anything into it since the reaction is balanced. And number of electron exchange is nothing but the n factor. What is n factor? See, equivalent weight of KbRO3 in the following. So the formula we have for equivalent weight is equals to molecular mass divided by n factor. Okay, molecular mass divided by n factor. So n factor in redox reaction in this case will be the number of electron exchanged per molecule. Per molecule. Okay, so here you see the number of electron exchange is the number of electron exchange is 10, right? And the number of molecules is 2, right? So n factor, if you calculate, that will be equals to the number of electron exchanged divided by per molecule, that is 2, which is nothing but 5. Okay, so the equivalent weight of KbRO3 will be its molecular weight divided by n factor, which is 5, and hence the answer is option D. Very simple one. Okay, next question. What is the answer of this question? In the standardization of Na2S2O3 sodium thiosulfate we have here, using K2Cr2O7 by iodometry, the equivalent weight of K2Cr2O7 you have to find out. Okay. So in this question, what we'll do, how the reaction of K2Cr2O7 takes place. Okay. So in hydrometry, we know this reaction takes place in acidic medium. Okay, in iodometry, the reaction takes place in acidic medium. This information you should have, iodometric titration. Okay, and we know in acidic medium Cr2O7 2 minus, it converts into Cr3 plus in acidic medium H plus. This is the conversion we have. So what we have to do, we need to just balance this reaction, and then we'll get the number of electron exchanged per unit per molecule, and then we'll get the molecule equivalent weight. Okay, so how do we balance this reaction? First of all, we'll balance the atom other than oxygen and hydrogen. So we have two chromium atom here. So 2 Cr3 plus. Oxygen we have to balance, and to balance oxygen we'll add H2O. How many molecules of H2O we add? 7 oxygen we have. So 7 molecules of H2O. Right? 7 molecules of H2O. To balance this, we'll add H plus on the left hand side. So for 14H here we have. We should also add 14H plus to the reactant side. Now we'll balance the charge. And how do we check the charge here? Total charge here, it is what? 14 positive and 2 negative. So 12 positive charge. And here the total charge is what? H2O is neutral, and this is 6 positive charge. And 12 to 6 we have to go. So it means we have to reduce the charge by 6. So for that purpose, we'll add 6 electron here. Okay. So N factor for this reaction will be what? The number of electron exchange, which is 6 per unit molecule. We have only one molecule of this. So N factor is 6. So equivalent mass or equivalent weight is equals to molecular mass divided by N factor, which is 6, and hence the answer will be option B. Right? Next question you see. Question number 4. The equivalent weight of KMnSO4 in acidic, neutral, and alkaline medium, respectively, or molecular weights of this is given. Okay. So basically, we have to find out the N factor in all these. One correction you make here, they have given KMnO4, right? So here also we should have KMnO4. So do this correction. Okay. You see, in this question, we know KMnO4 is nothing but MnO4 minus. MnO4 minus. So there are 3 different medium we have: acidic, neutral, and alkaline. Okay. Acidic, and then we have neutral, and this is alkaline. Okay, if you see the oxidation number of manganese here, it is +7. So we know MnO4 minus in acidic medium converts into Mn plus 2, right? In neutral medium, it converts into Mn plus 4. And then in acidic medium, it converts into Mn plus 6, right? So here, the N factor is what it is, the change in oxidation number, right? N factor is nothing but the change in oxidation state, oxidation number. So for this one in acidic medium, the N factor will be 5. For neutral medium, the N factor will be 3. And for alkaline medium, the N factor will be 1. Okay, so the equivalent mass in acidic medium, that will be molecular mass by N factor, which is 5. So molecular mass is 158, N factor is 5, 31.60. Okay, equivalent mass in neutral medium, that will be molecular mass by N factor is 3. So 158 by 3, 52.67. Equivalent mass in alkaline, that will be M divided by 1, which is nothing but 158. So answer is C, option C. Right? Next question. Solve this one. The oxidation number of phosphorus in B in this compound and xenon in this compound. Oxidation number. Okay, you see the molecule is BaH2PO2 whole twice, make it close. So barium, we know it is in +2 oxidation state. right? So here the total charge on this part of the molecule is -2. Hydrogen is always in +1, right? Phosphorus we have to find out, so we'll assume X. Oxygen always -2. Okay, so for this part, you see, for this part, what we'll write, only for this part I'm taking. For hydrogen, 2 into 1 plus phosphorus is X plus 2 into -2, and this is multiplied by 2 because whole twice is also there, and this is equals to -2. Okay, so when you solve this, this 2 minus 2 becomes -4. So we'll have 2 into -2 plus X is equals to -2. So X will be equals to +2. Yeah, right? Just to check the calculation. If it is +2, so next one you see Na4 XeO6. Na plus 1 Xe, I assume X and -2. So it is 4 into 1 plus X plus 6 into -2 is equals to 0. So when you solve this, you'll get X is equals to +8. X is +8 and +1. Okay, so I'll just let me check the calculation here. BA +2, so it is -2, so it is -2 -2 +2. Okay, so 2 plus 2 into. Oh shit, I made a mistake here. You see, this bracket is not here. This is actually here. It is present over here. You see this? Okay. So we'll have here also, this bracket will not be there. And we'll have a bracket over here. So basically, we'll have 2 plus x -4, right? So we'll have +2 also here. And that will be equals to -1 this side. Okay, so when you solve this, so -4 -2, -4 -2 -2 -2 will go this side, so we'll get +1 here. +1. So answer will be +1 and +8. So option C is correct. Yeah. Next question. In which of the following pairs there's a greatest difference in the oxidation number of the underlying elements? So you have to find out the oxidation number and then maximum difference you have to find it out. What is the answer? See, the compound we have NO2 and N2O4. First pair is this, second pair is P2O5 and P4O10. Third pair is N2O and NO. And the last pair is SO2 and SO3. N2O4, nitrogen is in +4 oxidation state, and here nitrogen is in +4 oxidation state. So difference will be what? Difference here is 0 because we have to find out the difference, greatest difference. Here, phosphorus is in. What is the structure of P2O5? Structure of P2O5 is this: double bond O, double bond O, double bond O, and double bond O. Each phosphorus atom you see, it is in +5 oxidation number. Here also it is +5 oxidation state. So here also +5, here also +5, right? So difference will be again 0. How here it is +5? N2O, nitrogen is in +1, this is +2, this is +4, and this is +6. Here the difference is 1, and here the difference is 2, right? Hence, the answer for this question will be option D. Next question you see. Where are others I made? There's no one, I guess. I was thinking of sending this as a test paper because none of you were there. I have taken almost half an hour, more than half an hour, it's almost 40 minutes. Okay. So I think only you are there. Tell me the answer this question. A, you are getting A. A is ions having positive charge, cation, correct? B is sum of the oxidation number of all atoms in a neutral molecule. Should be 0, right? So B is 4. Oxidation number of hydrogen ion, it's +1. So I think C is 3, yeah. Oxidation number of fluorine in NAF, -1, 2. And E will be 6, right? So A is correct. Next question you see. Tell me this one. 8th one is C. Nitric oxide act as a reducing agent in the reaction. So I mean in option C, you check the oxidation number of nitrogen atom, both side, reactant side and product side. What is the oxidation number? If it is a reducing agent, so its oxidation number should increase, correct? Check that. Yeah, correct. B you can say easily because you see, first of all, this iodine is getting reduced. Okay, you see the reaction we have 2NO plus 3I2 plus H2O gives 2NO3 minus plus 6I minus plus 8H plus. So since reducing agent they are asking, right? So you have to look at the compound which is getting reduced first. Okay. So which you can easily see iodine from 0 to -1. So it is getting reduced, right? So since this iodine is getting reduced, so this is acting as a reducing agent. It reduces the iodine. So oxidation number of NO here is +2, and that of NO3 minus here we have +5. Okay, so nitric oxide act as reducing in the reaction is option B. Sorry, yeah, B. Okay, next question. The oxidation number of elements in a compound is evaluated on the basis of certain rules, which in the following rule is not correct in this respect.
Saimir is getting D. Shreyash, is it plus one in HOF? You check once. First option is also wrong. First is not correct. And fluorine always have minus one oxidation number. D option is correct. Yes, did you check that? See, in case of hydrides, yeah, correct. In case of hydrides, hydrogen also have minus one oxidation state, right? So the oxidation number of hydrogen is always plus one. That is not correct. Okay, it is wrong. But if you see in all its compound, the oxidation number of fluorine is minus one. A is definitely not correct. Okay, just use give me a second. I'll just cross check this option D. Fluorine, but there's a rule. which says fluorine has, since it is a most electronegative element, so fluorine always have -1 oxidation state. The fluorine is the most electronegative element, so it is always -1 oxidation state except F2 where it is 0. So in HOF, H has +1, O has 0, F has -1 oxidation state. There's no way F will never ever have oxidation state +1, OF2, oxygen diprotide. Yeah, correct. That's what it is. Oxygen will have 0 oxidation state here in HOF, right? Generally, this charge we only defines or we explains on the basis of electronegativity. So in HOF, hydrogen is +1, this is -1, and oxygen is in 0. Right? So you must keep this, and this is the rule we have done in the assigning the oxidation number of any elements. That fluorine being the most electronegative element, its oxidation number is always -1. Right? So if we have to, choose between A and D, definitely A is wrong. Okay, so we'll go with option A. In somewhere it is also explained this thing HOF. That's why you are getting confused now. HOF, in somewhere they have explained this, that fluorine is +1, oxygen is -2, and hydrogen is +1. This is also written somewhere in the book, right? But we'll consider this only according to electronegativity. And the rule itself says, because it is given, you see the question here, the oxidation number of element in a compound evaluated to the basis of certain rules. Okay, so rule itself says that fluorine being more electronegative element, its oxidation number is always -1 in all its compound. That's why we'll go with option A. Question number 10. A is correct. 0, +1, and -2. Why it is C? Shresh. H2S you consider as H2O only. H2S similar to H2O, it is -2 and it is +1. That's why it is -2. Okay, 10th one is A. Oxidation number of oxygen arranged in increasing order. Okay, it is definitely maximum for OF2. Okay, and that is given in only one option. See, in BaO2, it is peroxide. Okay, so here the oxidation state of oxygen is -1. It is a peroxide. What is KO2? KO2 is a superoxide. Superoxide. And oxidation state is -1/2 for oxygen. O3 is ozone 0. And OF2, it is oxygen difluoride -1, so +2 on oxygen. So obviously, the oxidation state of oxygen is maximum in OF2 and minimum in BaO2, right? Hence, option A is correct. Okay, this is the elements of group 1. Okay, so this forms oxides of this type. Peroxides of what? Na2O2 type. Na2O2 type peroxide it forms, and it also forms normal oxides of Na2O type. Elements of group 1 forms normal oxide of this type, peroxide of this type, and superoxide of MO2 type. Okay, this you must remember. Next question. Is it D? Bromine is getting reduced also and oxidized also, right? So bromine is getting reduced as well as oxidized. So hence it is option D. Okay. Can you tell me the oxidation number of bromine here, here, and here? Here it is 0, -1, and here it is +5. -1 and 0. Right? So oxidation number is getting reduced and increase also. That's why oxidation and reduction both takes place. Next one. Yes. The largest oxidation number exhibited by an element depending on its outer electronic configuration. With which of the following outer electronic configurations the element will exhibit largest oxidation number? So it is when all these electrons present in d and s orbital takes part in the bonding, then the oxidation number will be maximum, right? So we have maximum electrons for option D. So when all these electrons takes part in bonding, the oxidation state will be +7. Here it will be +3. Here it will be +5. And here it is +6. So maximum is for this. Okay, hence answer will be option D. Yeah, that also you can say. Manganese. Okay. So for phosphorus, we have to write down. So outermost electronic configuration will be what? 3s2, 3p3. This is the outermost electronic configuration. So the minimum oxidation number possible when it accepts 3 electron, and maximum oxidation number possible when it releases all electrons of valence shell, right? So minimum possible, this is for minimum, sorry, it is accepts A double C. And this is for maximum oxidation number. So minimum will be what? When it accepts 3 electrons, since it requires 3 only to gain octet. So minus 3 will be minimum and maximum will be plus 5. This is easily you can say from the electronic configuration. There is one formula of this also that I'll write down here, that for p block elements, the highest negative oxidation number is equals to the number of electrons in the valence shell, minus 8. So when you see this number of electrons in the valence shell is what? 3 plus 2, 5. 5 minus 8 is equals to minus 3. And the highest positive oxidation number is equals to group number minus 10. So this phosphorus belongs to which group? 15th group. Minus 10, that is equals to 5 plus 5. So minus 3 and plus 5, option C is correct. 15. What is this? I think with lithium it gives lithium iodide. I think something is wrong here. It should be lithium hydride. Why? I'll tell you this. Yeah, there's a mistake in this question. First of all, you see the first option. When iodine and hydrogen combines and it forms iodide. So here hydrogen is in +1. Here it is 0. Right? So it is getting oxidized. Iodine is getting reduced. Right? So oxidized means what? It is a reducing agent. Third option. This is option A. Third option. Nitrogen combines with H2 to gives NH3. We are not concerned with the balanced equation here. If you want to balance it, it will be 2NH3 and 3H2. It is 0, again -1. Sorry, +1. 0 +1, correct? So again you see hydrogen is getting oxidized. So here also it is a reducing agent. Option D you see, sulfur plus hydrogen gives you hydrogen sulfide. Again hydrogen here +1. So oxidize. Hence here also it is a reducing agent. So here in this option, option B, they should write here lithium hydride, not iodide. It should be lithium hydride. So you see the reaction Li plus H2. It forms what? 2 LiH hydrides of first group, that is alkali metals. It is -1 and here it is 0. So it is getting reduced, right? It means it is an oxidizing agent. Hence the answer will be option B. Yeah, okay, fine. But the point should be this, okay? Option B is correct. Next question you see. Sixteenth, you are getting D. Tell me the oxidation state of nitrogen, both nitrogen atom. 6 and -4, is it? You check again. Is it 6 and -4? 5 and minus 3. Yeah, it's correct. It should be 5 and minus 3. See, NH4NO3 is an ionic compound. This is an ionic compound. So it actually exists in the form of ion, which is NH4 plus and NO3 minus. So if you find out the oxidation number here, it is plus 5, and here it is minus 3. So plus 5 and minus 3, not 6 and minus 4. Answer is option B. What is the answer? 17th. Sir, will it be in N3, N3H? Okay, okay, we'll see the previous one you were asking, right? Okay, you see this 16th one first. N3H is what? The structure of N3H is this: N, double bond N, double bond N, and then H. So this nitrogen will have positive charge and this nitrogen will have negative charge. Right? And this hydrogen is plus 1, so this nitrogen will also have negative charge over here. Right? Charge, if you want to see, if on whole this will have one negative charge. Like this, if I write, it is one negative charge onto this. So oxidation state on this nitrogen atom, if you try to find out, this one X is equals to -1. So total charge on nitrogen atom is what? Is -1. So charge on each nitrogen atom is -1 by 3. So it is same. They are talking about oxidation state. So oxidation state is nothing but the average value. Okay, oxidation number is the it for oxidation number we'll check each oxygen atom. Is it clear? So in N3H, the charge on each nitrogen atom is minus 1 by 3. Understood? Okay, 17th one you are getting C. SO2 passed through an acidified solution of potassium dichromate. The oxidation state of sulfur. Okay, so we'll write down the reaction first. And what is the reaction we have here? SO2 passed over an acidified solution of potassium dichromate. Okay, so potassium dichromate is K2Cr2O7, and this with SO2 in acidified solution. So that suppose we have H2SO4, and the product we get here is what? K2SO4 plus Cr2SO4 whole thrice plus SO3 plus H2O. This is the product we get. So change in oxidation number is what? Here the oxidation number of sulfur is plus 4, and here the oxidation number is plus 6. The question is the oxidation state of sulfur changes from plus 4 to plus 6. Hence option C is correct. Okay, that's what you also got. 18th one you see. See, one thing you must keep in mind, they won't ask you this question directly. The question that we are solving today, they won't ask you these questions. But like questions like, the questions of like electrochemistry, Faraday's law of electrolysis, and then the question of equivalent concept. There you required to find out the change in oxidation number. Okay, that's why these questions are important. Okay, they won't ask you these directly, but application of this you must have. Application of oxidation number you must have in other questions. That is why we are doing this. Okay, 18th one. In which of the compounds does manganese exhibit highest oxidation number? Highest oxidation number of manganese is what? It is there in. Oh, we have to find out then. So MnO2 it is plus 4, right? Mn3O4 it is plus 8 by 3. K2MnO4 plus 6, and MnSO4 it is plus 2. Right? So highest oxidation number, if you have to find out, that will be in KMnO4, which is 2 into 1 plus x minus 8 is equals to 0. So x is equals to plus 6. Option C. Correct? In MnSO4 it will be plus 2. Here plus 8 by 3. Here plus 4. So minimum value will have what? Will have in MnSO4. Minimum value. This one you solve. 19th is D. Shreyas is getting D. Here it is 10 ml of 1 molar. It is the concentration given 10 ml of 1 molar. So we have to find out the oxidation state of cerium in the reduced product. Okay. Now you see this Sn plus 2 releases 2 electron and goes into Sn plus 4. Right? So for this, the N factor is what? The N factor is nothing but 2. Okay. And for cerium, we do not know the N factor. Okay. So what we can write that number of equivalents of cerium is equals to the number of, okay, we have milliliters, so I'll write down the number of milli equivalent. Here also the number of milli equivalent of Sn 10, right? So number of milli equivalent of cerium is what? It is the number of moles into N factor, right? And number of moles will be what? It is molarity, number of millimoles. So molarity into volume. This volume should be in milliliter into N factor. This is for cerium is equals to the molarity into volume in ml into N factor of 10. So for cerium it is given that 40 ml volume we have into molarity is 0.5, right? N factor we do not know, is equals to molarity is 1, volume is 10, and its N factor is what? We have calculated 2. N factor of cerium, if you see, you'll get 0.25. So it is 10, 20. Oh, we'll get N factor, we'll get 1. Okay, this is the N factor of cerium, right? Means what? 1 electron is required for the conversion. So C4 plus we have initially. For N factor to be 1, we must have 1 electron. Like here you see 2 electrons are there, so N factor is what? 2. So for 1, we must have 1 electron, and it gives Ce3 plus. So hence the oxidation state of cerium in the product is plus 3. Answer is option B. Correct? Yeah, right, Saimir. Understood, Shreyash? Just number of equivalents we have to equate. Next question.
Yes, that's why I always say read the question carefully. Okay, don't assume always. Okay, usually what happens once if we study two, three lines of the question, half of the question, then we start assuming that question. Okay, the question is this. So don't do this. Finish the question first, read out carefully, and then you try solving it. Question number 20. Saimir is getting B. Shreyas, tell me the answer. All of you are getting B. So I'll just write down HNO3, NO, N2, and NH4Cl. HNO3, the oxidation number is +5. Here it is +2. Nitrogen it is 0. And since it is an ionic compound, so it is -3. Right, so this is the decreasing order. You see it is decreasing +5 to +2, +2 to 0, and then 0 to -3. Hence the answer will be option B, decreasing order of oxidation state. Yeah, next question. Saimir is getting B. Shreyas, Okay, you see this question, you need to draw the structure of this compound. Okay, S4O6 2 minus. Okay, S4O6 2 minus. It is actually Na2S4O6, or you can also compare this with H2S4O6. When two hydrogen is replaced by Na, you will get this salt. The structure, if you see, the structure is like this: S double bond O, O minus double bond O, S, 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 double bond O, O minus, and double bond O. This is the structure. If you draw this for H2SO4, right, then here will be OH, OH. If it is Na2SO4, Na plus, Na plus. Correct? So this is the structure we get here. Okay. So now in this structure you see, because of this double bond, the charge on this sulfur is +2. This single bond, the charge here +1. This double bond, the charge here it is +2. So +2, 1, 3 and 2. So here the oxidation state of this sulfur will be +5. This is one type of sulfur atom here. Similarly, the oxidation state of this sulfur atom is again +5. Right? 2, 4 and 1, 5. This sulfur atom, it is connected with sulfur itself, both sides. So there is no electronegativity difference. Oxidation state is 0. Here also with the same logic, it is 0. So there are two types of sulfur atom here we have. One atom in which we have +5 oxidation number and other type in which 0. So the difference in oxidation number is 5. Yes. Why it is 0? Because you see, both sides we have sulfur atom only. So there is no electronegativity difference. That's why it is 0. Right? Why I'm taking a charge here? Because sulfur and oxygen will have electronegativity difference, right? So oxygen will be slightly negative, this will be slightly positive. Since two bonds are there, so this 2 contributes +2 charge, this double bond contributes +2 charge, this single bond contributes +1 charge, and this bond, since it is sulfur only, so this bond contributes 0 here. So 2, 4, 5 and 0, so +5. Is it clear? Next one. How it is D, Shreyash, and how it is C, Saimir? Yeah, that's good. So this information you should have. You cannot do this question. Okay, this you should know. You should have this information that when this potassium dichromate, that is nothing but Cr2O7 2 minus in acidic medium, combines with more salt. More salt has Fe plus 2 ion. Fe plus 2 ion. So it gives chromium 3 plus. This is, we know already, because this chromium is plus 6 over here. So this converts into Cr3 plus in acidic medium. Plus we'll get H2O, 7 moles of H2O we get here, and then we'll get Fe3 plus. And if you see this reaction, we'll get 6 moles of this and 6 moles of this. So the ratio should be 1 is to 6, right? 1 is to 6. And hence we can say the number of moles of more salt required per mole of dichromate is 6 mole. Answer is option D. This you have to memorize. Okay, because you don't have to write down the equation. That equation you cannot memorize. You can balance this, you'll get this 6 by balancing the equation, and for that you should know what all products are there so that you can balance these equations. Right? Or if you know this thing that Fe2 plus converts into Fe3 plus, like this you see, Fe plus 2 converts into Fe plus 3. This you should remember. Okay, so the number of electrons exchanged are 1 electron here. And if you take this Cr2O7 2 minus plus H plus gives 2Cr3 plus, right? So if you balance this oxygen, you have to add 7H2O this side. 7H2O means 14H plus. 14H plus, the total charge here it is what? Plus 2, so plus 12, right? Here you see the total charge here it is what? 14 plus and 2 minus. So 12 positive charge we have here. And here the total charge is what? 6 positive charge we have. So to balance this charge, we have to add what? 6 electron here. So 12 plus minus 6 gives you 6. Okay. So now when you add these two equation if you add, so we have to add in such a way that these electrons get cancelled. So this reaction we have to multiply by 6. So we'll get 6 Fe2 plus, 6 Fe3 plus and 6 electron. And then when you add this, electron gets cancelled, we'll get 6 moles of salt here. Right? So that is why you are getting 6 moles of more salt. So ratio should be 1 is to 6. Answer will be 6. So what you have to keep in mind here, this reaction, if you don't remember, you have to understand that in acidic medium, more salt Fe2 plus converts into Fe3 plus, and then you can balance the equation according to the rule that we have for balancing a redox reaction in acidic medium. Follow that rule, you'll balance these equations and you'll get the mole ratio. You understood this? Any doubt in balancing of these reactions? Any doubt? Tell me. Understood? Okay, guys, we'll do one thing. I'll take a break for 10 minutes, okay, because I have to take my lunch because after this class, this class we have till 2:30, okay? So I have to leave for Rajaji Nagar after 2:30 quickly, okay? So I can't get late. We have some, mock interview there for KV where we are conducting a mock interview there, okay, today. So I have to leave at 2:30 for Rajaji Nagar, okay? So I'll take my lunch quickly and then we'll resume the class at 2 o'clock. Will it be fine?
Okay, so you can also take your lunch. We'll start at 2 o'clock.
Fine. We'll take a break now. Okay, guys, can we resume the class? Okay, next question you see. Is this. Can you tell me the formula of hematite and magnetite? What is the formula of hematite? See, again, this is nothing, but if you do not know the formula, you will have that doubt. Hematite is Fe2O3 and magnetite is Fe3O4, right? So in Fe2O3, we know the oxidation state of ion is Fe is in +3 oxidation state, right? But this molecule actually exists in the form FeO.Fe2O3, correct? So here it is +2 and here it is +3. So in magnetite, +2 and +3, right? In magnetite, +2 and +3 and +3 in hematite. So answer is option D. Understood? Nothing was there in this question, but the only thing you should know the formula. And this thing we have discussed many times. Okay. See, these kind of questions, this is an informative questions. You cannot put any logic into it. If you do not know this formula or if you have any doubt into this, there are all possible options. You cannot do this question. That's why chemistry at some point it is difficult. If you know, it will take hardly 2, 3, 5 seconds. Okay? If you do not know, you'll waste your time also, and you do not know whether you will end up with wrong answer or right answer. Okay, that's why these kind of things you should write down in a notebook, which you can revise in the last day of exam, last 3, 4 days before. Right? Those kind of preparation actually it is required. Still, you have time. Okay, you can do that also from now onwards. That will help you a lot. Next question you see. All these question you see, I have chosen this question because these are the information based question. Maybe they won't ask you this question directly, but this information maybe it requires to solve questions in Faraday's law of electrolysis or calculation of equivalent weight and all. That's why I have chosen this question. Done. 24th one you are getting A. Okay, why you took so much of time in this? We simply know that potassium dichromate is K2Cr2O7, right? Which we can write it as in ionic form Cr2O7 2 minus. And Cr2O7 2 minus in acidic medium, it converts into what? 2Cr3 plus. That is it. No, we know this already. You have this information. For few molecules, the change in oxidation number you have to memorize. Okay, so it always converts into +3 oxidation state. Answer will be A. That is it. You don't have to write down the reaction and all. Understood? Okay, next question you see. This one. Is it B? MnO4 minus is oxidation respectively are. So 1, 2, 3, 4. Okay. So from here to here, +7 to +2, change of 5 we have. So when you got 5, these two you can eliminate easily, right? Then here it is +2, and here it is +6, so +4. So answer will be B, right? Okay. Next question you see, I'll just give you this question. This is not the the image I have. For this reaction, you see, I'll write down the question. For this reaction, Cn minus, which converts into CnO minus. For this reaction, which of the following statements are true? Okay, so first statement, first option I am giving. Carbon is losing 2 electrons per atom. The first option is carbon is losing 2 electrons per atom. B. Oxidation number of carbon increased from oxidation number of carbon increased from +1 to +3. Oxidation number of nitrogen remains unchanged. D. A and C both are correct. Tell me this one. Is it D? Okay, I'll do this. See, Cn minus is nothing but this C triple bond N, right? In Cn minus, we have carbon negative sign bonded with triple bond N. And this convert into O C triple bond N minus we have here. So minus charge we have on oxygen here and it is on carbon. So if you see the oxidation number of carbon here, it is -3 on this nitrogen. I'll change the color just a second. We'll have -3 on nitrogen. So +3 on carbon, -3 +3. Why minus here? Because it is more electronegative. So -3 on nitrogen, so +3 on carbon, minus sign we already have on this carbon. So carbon will have +2 oxidation number here. Similarly, here nitrogen will be at -3 only, triple bond, so -3, no change. So first of all, the oxidation number of nitrogen remains unchanged. So option C is correct. Okay, and C is also there in option D, so we'll check option A also whether it is right or wrong. Right? So you see here the oxidation number of carbon here, it is what? -3 this side, so +3, -1 this side, so +1. Okay, so carbon here it is at +4. Right? So oxidation number of carbon is increasing from +2 to +4. It means carbon is losing electrons. Then how many electrons? 4 minus 2, 2 electrons. It means what? Carbon is losing 2 electrons, right? So hence option A is also correct, right? Our answer will be option D. This one is obviously not correct. One, it is 2 to 4, not 1 to 3. Understood this? Clear? Okay, next question. You see this reaction, I'll write down XmNO4 minus plus YC2O4 2 minus plus ZH plus, and it gives XMN3 plus 2Y CO2 plus Z by 2 H2O. You have to find out the value of X, Y, and Z. Options I'll give you. It is 2, 5, and 8, 2, 5, and 16, 5, comma 2 and 8, 5, comma 2 and 16. Is it option B, Shreyash? Okay, so what have you done? You have checked the option, right? Tell me, did you check the options? Did you check the option or you have solved it? Okay, yes. So you see, in this kind of question, when they are asking X, Y, and Z, okay, so it is the best way to cross check the options. Just you put all these options here and you check whether the elements are balanced or not. Or if elements are balanced, charge are balanced or not. That also you have to check. Okay. So two things you must take care of. There are sometimes, and when elements are balanced, charge will also be balanced, but then you have to keep that also in mind. But sometimes what happens, and when you put this 2, 5, and 16 here, you'll see all these elements will be balanced. Okay, that is the way to solve this question when they're asking X, Y, and Z. But suppose the option is not this, and the question is in this only. If they ask find the value of X into Y into Z, product of this, like this they can form any expression. Like suppose they can also ask you Z into Y by X. They can also ask you Z plus X plus Y. Any combination they can, whatever they want they can give you. But when you have questions like this and the options are given A, B, C, and D, okay, then it is difficult to cross check those because you don't have exact value of X, Y, and Z, right? If you multi product is some value you have, suppose we have 160, so the factor of this can be anything, right? And it is very difficult to solve those questions with the help of options, right? So the point here is what, when you have questions like this, then you have to balance this equation according to the rule. Yeah, they can ask you this question in the integer type. Okay, so the point I'm trying, I knew this thing that you can put this option and you'll get the answer. That is not a big deal, but this is what I wanted to discuss. Okay, when they ask you question like this type of question, usually they ask in integer type, and even in multiple choice they can also ask. They'll give you 4 options, 4 number they'll give you. Okay, so when the question is like this, you have to balance this equation. And to balance this equation, what are the information you should have? The information we should have is what? The reaction is in acidic medium, right? And acidic medium, this converts into this. Accordingly, you can have the rule. this converts into this. One is oxidizing part, other one is reducing part. Write down the both half equation, balance that equation according to the rule, and then you add, so that the number of electrons gets cancelled. Okay, and then you will get the value of x, y, and z. Accordingly you will find out the expression. You understood this? Is it clear? Okay, guys, I'll wind up the class here only. It is like it's already the 2:30 is there. I have to leave for Raji Nagar. Okay, so it takes time also. So I'll wind up the class here only. Okay, I hope you understand all these things. These section that I have done today, right? Just you keep those thing in mind, that in which condition the reaction, what kind of reaction takes place, how the oxidation state, oxidation number is changing. Like I'm repeating these thing again and again. Okay, you have application of these thing in other questions. Okay, so must do these questions. Okay, so anyways, in the next class we'll start, probably alkyl halide will do. Okay, so we'll wind up the class here only. Hope you understand all these things. Okay. Okay, thank you guys. See you soon.